As you can see on the screen, we have completed our collection interface. Okay, this was a long process. We completed collection interface, the child interfaces of collection interface, that is list, set and queue. Correct. In the list we completed the array list class, the linked list class, vector and stack. Here vector and stack are legacy classes. Okay, now the set interface, the difference between list and set interface, the difference between list, set and queue. What is the difference between hash set, sorted set, navigable set, tree set, linked hash set? We have done many things. The next thing that we are going to discuss after collection interface is map interface. Now collection interface is the root interface for only this part of the collection framework. For the rest of the part, map interface is my root interface. Okay, so we will begin with map interface. So what is map interface? If we want to represent a group of individual objects as key value pairs, then we should use map interface. Now in collection interface, if we want to represent a group of individual objects not as a key value pair but as a single entity, at that time we used collection. But when we need a key value pair type of scenario, then in that scenario we will use map interface. For example, I have shown this example before also. We have a key value pair 101 Tony, 102 Steve. So key is 101, 102, 103, 104 and the values are Tony, Steve, Thor, Bruce. Correct. Next is a map cannot contain duplicate keys. Okay, so these keys cannot be duplicate but the values can be duplicated. Okay, and each key can map at most to one value. Duplicate values are allowed. The next point is each key value pair is known as entry. So this is a key value pair, that is 101 and Tony. This is known as an entry. Correct. So this here is known as entry. Fine. So this is an entry. So what is an entry? A key value pair is known as entry. So a collection of entries object is known as a map. A collection of entry object is known as a map. Also remember that key is also an object and value is also an object. And a collection of entry objects, because key and value are objects, entry is also an object. So a collection of key value pair is known as a collection of entry object is known as a map. Fine. Next point, the methods in map interface. So first method is put method. So in these methods, they are different from the collection method. Okay, because map interface is not a child interface of collection. These methods are different. Why? Because we want to add key and value both, not just the values. Correct. So put method is used to add or insert an entry in this map. So key and a value together is known as an entry. Therefore, we have written that this method is used to insert an entry in this map. Correct. Next point, put all. If you want to insert another map into this map, you can also do that using put all method. Next is remove. If you want to remove a key, a delete an entry from a specified key. Okay, now how this works is, let's see. So for example, that I want to remove Thor. So to remove Thor and using the remove function, using the remove method, what we should know that what is the key of Thor. Okay, to remove Thor, we should know what is the key of Thor. So the key of Thor is 103. So if I write remove 103, so using this key, it will delete the entire entry. So this 103 and Thor will be deleted. Okay, so this method is used to delete an entry for the specified key. Next is get. Okay. This method is used to return the value of the specified key. Now if I want to get Bruce, fine. So what I will write, I will simply write get 104. So when I write get 104, it will not give me the key, but it will give me the corresponding value of that key. So my output will be simply Bruce. Next is public boolean contains key. Okay, if you want to check if some key is there or not inside your map, then you can use contains key method. So if I want to check if 102 is inside map or not, I will simply use the method contains key. Correct. So contains key and I will pass 102. If 102 is present, it will return me true, and if 102 is not present, it will return me false. Fine, because this is a boolean method. As you can see, this is a boolean method. Next, contains value. If you want to check value is present or not, for example, in contains value I pass Tony, so it will return me true. But if I pass Thor, it will return me false because I have removed Thor in the first step, as you remember. Okay, so this is contains value. Next is public set key set. Now what this is? Now as you can see, the return type is a set. Okay, we have learned many things about set and collection. So this is a return type set. So this method is used to return the set view containing all the keys. So if I write set key, If I write key set, the method name is key set, what this method will return me, 101, 102 and 104, 101, 102 and 104. As by now you have noticed, whenever I use square brackets, okay, this means collection. That set, list, there are so many outputs I have shown you. In all the outputs we use square brackets. For map we use curly brackets. Now we are using key set function on a map, but the output is of type object, is of type set, correct? So it will return me 101, 102, 104 in a set view, as you can see here. Now the next one is entry set. So this method is used to return the set view containing all keys and values. Okay, if I use entry set, so the output will be all keys and values. Entry set. So the output will be all keys and values in a form of set. So output will be something like this: 101 equals to Tony. Okay, 102 equals to Steve. So this is how the output will be if I use entry set method. Now the next one is collection values. Now the return type here is collection, not set. Okay, so this method returns the collection view containing all the values. Okay, so if I use values, then all the values will be returned. Okay, all the values. Now why for values we use collection and why for key we use set? The reason is simple. In set, duplicates are not allowed, and in collection duplicates are allowed. In the list, duplicate is allowed, but in set, duplicates are not allowed, as you can remember. Fine. So because duplicates are not allowed, and in key also duplicates are not allowed, therefore when we return key, there at that time we use set. Also in case of these entries are unique. Why? Because the key is unique, therefore we use set in that case also, but values can be duplicated. In this case we use collection. Okay, so this is the reason why in set, key set and set entry set we use set, and why for values we use collection. Fine. So these three methods are called collection views of map. Because in the map interface we are getting collection views. Okay, collection interface views. Fine. So these were some methods in map interface. Now we will see entry interface. So what is entry interface? Let's get to it. So entry interface is defined inside map interface. Okay, so inside map interface, okay, somewhere we have our entry interface also. Fine. What this entry interface does, it provides me with three methods. How many methods? Three methods. In the last example you have seen, either we should know the value of key to get the value of value, correct? We should know what is key to get its value. Okay, or we were only accessing key value together. What if I want to access key as one and value as something else? Okay, at differently, without knowing the value of key, what if I need the, without accessing key, what if I need value? So in that case we will use entry methods. We will use the methods provided by entry interface. The methods are object get key, so it returns the key corresponding to the map entry. Now what happens is, when we use entry, we are actually inside our map. Let me show you. So when I am talking about map, I am actually pointing here. Or here. So when I get key, so since I am pointing here in entry interface, the get key method will give me 101. And if I get the second method, that is get value, I will get Tony. So without knowing key, I can get my value also. If I am using entry interface methods. Okay, and how to use entry interface methods I will show you in coding. Fine. So the next is object get value. I told you about get value. Now the set value. Now what if I want to set the value of map with specified value v? Okay, now what will happen is, in the set value method I will pass a v. That is my new value. Fine. Now for example, I want to change from Bruce to Hawkeye. Okay, so what I will do, I will pass Hawkeye here in the set value, and if my map is pointing to 104, then what will happen? The value of this corresponding entry, that was Bruce, will be changed to Hawkeye. So I have to pass some value here. Fine. So these were the methods in entry interface. Now we have seen what map is. Now we will see its implementation class. All the methods till now what we have seen are just defined in the interface. They are not implemented. So they are implemented in hash map. Okay, and using the hash map reference variable, we can use these methods. So I will show you in coding after we discuss So I will show you these methods in coding after we discuss what is hash map. So let's have an introduction to hash map. So it is an implementation class of map interface. We have seen this. Underlying data structure is hash table. I have told you about hash table also. Insertion order is not preserved. Okay, the difference is insertion order is not preserved. Duplicate keys are not allowed, but duplicate values are allowed. No issue. Heterogeneous keys and values are also allowed in hash map. Okay, heterogeneous keys and values are allowed in hash map. Next point, it implements serializable interface. It is not thread safe. So this point is in multi-threading. Okay, so we will discuss this in multi-threading. What is serializable? What is thread safe? Fine. Just in case if someone asks you, you can tell them that hash map is implement serializable interface and it is not thread safe. Okay. So in case of key value pairs, if our frequent operation is search, then we could use hash map. Why? Because the underlying data structure is hash table, and in hash table searching is in order of one time. So if our frequent operation is search, and in the case of key value we have to use this, so we will use hash map. And in the case of single entity, we can use our hash set, which we have already seen. Fine. Now let's see constructors of hash map. So these constructors are exactly same as we have seen in hash set. Fine, they are exactly same. So the first constructor is new hash map. It is a default initial capacity with 16 and the field ratio 0.75. I have explained these points in hash set also. Next is, if you want the initial capacity, you can give the initial capacity by yourself. If you want the initial capacity and load factor to be given by the user, you can give that also. No issue. And the last one, it creates an instance of hash map with same mapping as specified map. So these are the four constructors. They are exactly same as we have seen in hash set. Okay, there is no much difference. So let's now code. In this code, I will simply show you these methods in action. Fine. So let's do coding. So let's now code. Okay. So hash map, and I will pass. I can pass integer for my keys and string for my values. Fine. Map equals to new hash map. Okay, no issue. Now let's see put method. Okay, so let me put some values, that is add values in my hash map. So put, and we have to pass two values. First is my key and the second is my value. Okay, so for this time we will use some anim names. So Dragon Ball. So now map dot put, and here let's see my value, key value be 4. Okay, and that note, no issue. Next one is map dot put, the key value be 2 and one piece. Okay, next one is map dot put, let the key value be 4 this time. Oh, 4 is already done. Let the key value be 5 and input. This time let's input something that everyone knows, Tom Jerry. Okay, so this is not any, this is cartoon. The next one is map dot put and 3 comma this time let's put Naruto. So these are my 5 values that I have inserted. So key is 1, 2, 3, 4 and 5, and the values are these: Dragon Ball, Death Note, One Piece, Tom and Jerry and Naruto. Fine. So let me print it. Let me print the map. So when I print the map, the first point was insertion order will not be preserved. Insertion order will not be preserved. So let's see if the insertion order is preserved or not when this run is completed. So as you can see here, the first one is Dragon Ball, second is One Piece, but I have inputted 4 as a Death Note. The second insertion was Death Note and the key value was 4, but here it has ordered to 1, 2, 3, 4 and 5, correct? So this was not the case. So insertion order is not preserved. Okay, so let me show you something interesting about the put method. So as we have seen that the keys should not be duplicated, but the values can be duplicated. Okay, so let me put some duplicated key. So map.put, just think what will happen if I put a duplicated key. Will I get a runtime error? Will I get a compile time error? Or will I get any error of any sense? So One Punch Man. So let's put One Punch Man here. Okay, and s out simply map. So now what will happen is no runtime error, no compile time error also. This One Punch Man will override the key value 4. Okay, so now at the 4, instead of that note I will have One Punch Man. Fine, instead of that note I will have One Punch Man, and the put method returns whatever is just overwritten. Okay, So what put method returns is the overwritten value. So that node is overwritten by One Punch Man, so it will return that node. Okay. In the previous cases that method since nothing was overwritten, the put method will return simply a null. Okay, just make these points. Okay, just write these down. So what put method returns is that the object that was overwritten. Fine. The put method returns the object that was overwritten. Okay, and in this case, since nothing was overwritten, the put method will return simply null. Fine. So this was an interesting point about put. Let's see the remove method. Remove method, and here I will remove a key with 3. Fine. So the entry with the key 3 will be removed, and let me print it. Simply map. So let's see what is the output. So entry 3, that is Naruto. Oh, I delete Naruto by mistake. No issue. So Naruto will be deleted, and I will have one is Dragon Ball, second is One Piece, fourth is One Punch Man, and fifth is Tom and Jerry. Okay. Now let's move further. So let's see the get method. Get method. Fine. So in the get method, what we will do, we will simply get something. So we will get, for example, Tom and Jerry. Okay. So s out. What we will do, s out map dot get, and tell me the key. So the get method requires key. So Tom and Jerry key is 5, so I have to write here 5. Okay. We will also see how to print the value if I do not know my key. Okay, using the entry interface. I have explained this. Fine. So we will also see this in this program itself. So as you can see, the output is Tom and Jerry. After get method, we will see contains key. Okay, contains key. Let's see. So s out, whether it contains or not, map dot contains key 2, map dot contains key 2. Okay, if it returns 2, if it returns true, then the 2 is present, that is One Piece, so it will be present. Okay, so the answer is true. I have deleted 3, so if I change it to 3, the answer will simply become false. After the contains key, we will see contains value also. Okay, so as you can see, the answer is false. Now let's see contains value too. So map dot contains value dot contains value. I have to write the value itself. So dragon ball. So let's see what is the output of this contains value. Fine, it is running and the output is false. Why the output is false? Dragon ball is present. No, but we have a space in between. So just take care of this. String is matched character by character, and space is also a character. Okay, now see, it returns me a true. Fine. So this was contains value method. So after contains value method, let's see some other methods. For example, key set method. What is the example? Key set. Now as you can see, they are curly braces. Yes, they are curly braces. Now key set will return me a set. So these will not be a curly braces, but these will be my normal, which we have seen in collection interface, the square brackets. Okay, so I will declare a set s1 equals to map dot entry set. Done. So this map dot entry set method, what it returns set. It returns an object of type set. Therefore will require a reference variable of type set. Okay, so we are not declaring an object of an interface. Okay, it is not possible. What we are simply doing is this entry set returns me an object of type set. Therefore I require a reference variable of type set and nothing else. This is this simple. Fine. Now system.out.println and s1 and s1, simply done. So if I print it, it will simply give me the value in square brackets. Okay, in square brackets. Okay, I've done a mistake. So this was entry set method. What entry set method gives? It gives me everything, all the entries inside my map. Okay, in the form of set. Now you can see the difference. Here they are curly braces, and here they are simply square brackets. Now let's see key set. Okay, key set method. Now in the key set method, for example, set s this time equals to map dot entry set. Key set again. So now simply s out, that is system.out.println and s. Fine. So now I will have my keys, only keys. Okay, that time I have my whole entry, that is key and value. This time I am having only keys, that is 1 to 4. And so now since I have my set, that is s1 reference variable, I can use all the methods of set and collection. I can use all the methods of set in collection, but not on my this curly braces one. That this is a map. We cannot use those methods on a map, but we can use those methods here. Correct? We can use those methods here. Fine. Now let me use iterator. Iterator itr equals to my s1, that is the reference variable of the set, dot iterator. Okay. Now let's go inside. Let's go inside my set itr dot has next. Fine. Now I am inside my set. I am inside my simply set. So if I want to use map dot entry, if I want to use map dot entry, okay, m1 for example, I have to typecast it to map dot entry. So itr dot next, what it simply returns me, it will returns me an object. Okay, but what I want to do, I simply want to, what I have to do, I have to typecast it. I have to typecast it to map dot entry. Okay, because I am inside set, I am typecasting it to map dot entry. Now I have the entry functions. Now also I have the entry functions. So now use entry functions. Okay, so there are 3 entry functions. I will use 2 here only. So m1 dot get key plus and here m1 dot get value. So 2 methods, m1 dot get key and get value. When iterator is iterating, so this is the first one. So first one is nothing but Dragon Ball, 1 and Dragon Ball, 1 and Dragon Ball. So it should print me 1 and Dragon Ball. Fine. So let's see, will it print me 1 and Dragon Ball or not? At the first while it will print me 1 and Dragon Ball. Then again while will execute, then it will print me 2 and One Piece, then 4 and One Punch Man, then 5 and Tom and Jerry. Okay. Now when I am at last, what I want to do, if m1 dot get key, m1 dot get key dot equals 5. Okay, so if the key equals 5, so I am talking about Tom and Jerry case. If the key equals 5, so what will happen is, I want to use the last one, that is m1 dot set value. I will change the value of Tom and Jerry for example Beyblade. Okay, so this I will change it. So what I have done, if my get key is equal to 5, I will change the value to Beyblade. So key 5 is for Tom and Jerry, so Tom and Jerry will now be changed to Beyblade, and let's see the output. Okay, so after this I will simply print my s out and I will simply print my map. Okay, so let's see. So as you can see, the Tom and Jerry is now changed to Beyblade, and I have 1 of Dragon Ball, 2 One Piece, 4 One Punch Man, and 5 Tom and Jerry. Because why 5 is Tom and Jerry is simply because here you can see, before checking it equals to 5, I am printing it. Okay, so before changing I am printing, therefore 5 is Tom and Jerry. And using m1 is a map object, therefore the value that is changed Beyblade, here I can see it in a map. Okay, that is not an issue. Now these were some methods, these were some simple methods that we have discussed in PPTs also. Okay, now I have coded them, almost all of them for you. You can try many different things here. There is not an issue. You can give your own capacities also. Okay, you can use different constructors. So this is all on you. I have explained each and every method that I have shown you in PPT. Okay, we have seen everything. So after the normal map, that is hash map, I will go to linked hash map. So you remember, after hash set we went to linked hash set. Okay, and there is just a single difference between these 2 points, and those 2 points also there were just 1 or 2 differences. Okay, so let's now see them. So this is my linked hash map. So linked hash map is a child class of hash map. No issue, this is not a difference. The difference is, here underlying data structure is hash table, and in the linked hash map the underlying data structure is hash table plus linked list. So these are the differences, and the differences are also same. If you remember, in hash set and in linked hash set the differences were exactly same. So in hash map we have insertion order is not preserved, and in linked hash map we have insertion order is preserved. So the differences are also similar and the changes are also similar. So in the code now I will show you this change, that the insertion order is not preserved in hash map. I have shown you this right now, and in linked hash map I will show you the insertion order is preserved. So let's now code again. So in this code only, what I will do, I will declare some more lines. I will write some more in this code only. What I will do, I will write some more lines. So here I will do linked hash map, not hash set, and I will pass again integer and string. Fine. and linked hash map equals to new linked hash map. I think you now have just till now you should be very familiar with these syntax. Okay, so use the put method, no issue. I will just use the put method and I will just input some values. So let's just copy paste these same values. Okay, copy, let me now just paste it and change this map to linked hash map. Okay, so after these changes, what I just want to show you is that the insertion order is preserved. I have shown you that insertion order is not preserved in case of normal hash map, but the insertion order will be preserved in the case of linked hash map. Okay, I am inserting 1, then 4, then 2, then 5 and 3. So in the same insertion order we will get our output. Okay, but what hash map did, it changed it to 1, 2, 3, 4 and 5. Okay, so as you can see here, we have 1, 2, 4, 5. Okay, one second, there is some mistake. Let me check and let me correct. Oh, I haven't output it. So output linked hash map. So the final answer that I've shown you was for this println line. So let's now again run it, and now you can see, let's see. Yes, now you can see that 1, 4, 2, 5 and 3. So the same order 1, 4, 2, 5, 3, 1, 4, 2, 5, 3. So the insertion order is maintained here, but the insertion order in the beginning, as you can see, was not maintained. I have 1, 2, 3, 4, 5, but here was 1, 4, 2, 5, 3. Fine. So in hash map, insertion order is not maintained, but in linked hash map, insertion order is maintained. This is the only difference, and the other difference is in the underlying data structure. And here it is hash table, and here it is hash table plus linked list. Fine. Hash map was introduced in 1.2 version. Linked hash map was introduced in 1.4 version, and these are the same differences as we have seen in hash set and linked hash set also. Fine. So this completes my map, my hash map, my linked hash map. Now we will see identity hash map and weak hash map. Okay, after these two, the hash map function will be completed and we will move forward to sorted maps.